Welcome to this section on data handling in data science. Data handling refers to the process of collecting, organizing, storing, processing, and managing data efficiently. In data science, data is the foundation for analysis and decision making. Before applying any machine learning algorithm or visualization technique, the data must be properly handled. Data handling ensures that data is accurate, consistent, secure, and ready for analysis. For example, an e-commerce company collects customer details, product information, and purchase history. Proper data handling helps the company analyze customer behavior and improve recommendations. Importance of data handling. Data handling is an important step because raw data collected from different sources is usually not ready for direct analysis. It helps in improving data quality. Data handling removes errors, duplicates, and missing information. For example, a customer database may contain duplicate customer records. Data handling helps identify and remove duplicates. Managing large data sets. Modern applications generate huge amount of data every day. Efficient methods are required to store and process this data. How to reduce the processing time. Optimized data handling improves the speed of analysis and support decision making. So, clean and properly organized data helps organization make accurate decision. Data handling workflow. The data handling process follows a sequence of steps. First is data collection. Data is collected from different sources such as database, websites, sensors, and application. Second step is data storage. Collected data is stored in files, databases, or cloud platforms. Third step is data cleaning. Cleaning removes missing values, duplicate records, and incorrect data. After cleaning, data is transformed into a suitable format. Finally, data is analyzed to extract useful insights. For example, a banking system collects transaction data, store it, clean errors, and analyze spending patterns. Types of data. Data can be classified into different types based on its structure. Structured data. So what do you mean structured data means? It has an fixed format with rows and columns. Example, Excel sheets, SQL databases, customer tables. Semi-structured data. Semi-structured data does not follow a strict table format but contains some organization. Examples, JSON files, XML files. Unstructured data. Unstructured data does not have a predefined format. Examples, images, videos, audio, social media, posts. Different types of data require different storage and processing units. Challenges in handling large datasets. Handling large datasets creates several challenges. The major challenges are large volume. Modern applications generate huge amount of data. For example, in social media platforms, it generates millions of posts every day. Second, data variety. Data comes in different formats like text, images, and videos. And data velocity. Data is generated continuously and needs quick processing. Fourth is memory limitations. Large datasets may not fit into computer memory. And data quality issues. Incorrect or incomplete data affects analysis results. Large volume. Data volume refers to the amount of data generated and stored. Today, organizations handle millions and billions of records. Traditional processing method may become slow when the dataset size increases. For example, a shopping website stores millions of customer transactions. To analyze this data efficiently, scalable storage and processing techniques are required. Second challenge is data variety. Data variety means data comes from multiple sources and formats. For example, a healthcare organization collects patient records, medical images, reports, sensor data. Combining and analyzing these different formats is challenging. So, data processing methods must support multiple data types. Third challenge is data velocity. Data velocity refers to the speed at which new data is generated. Some applications require real-time processing. Examples: stock market monitoring, online payment system, traffic monitoring. These systems must process incoming data immediately and provides quick results. Fourth, data quality. Data quality directly affects the accuracy of analysis. Common data quality problems include missing values. Some information may not be available. For example, customer phone number missing. Duplicate data. Same record may appear multiple times, and inconsistent formats. Different formats may exist for the same informations. For example, the data stored in different formats may reduce the reliability. Memory optimization techniques. When working with large data sets, memory optimization is very important. If a dataset is larger than available memory, the system may become slow or fail. Memory optimization techniques include choosing suitable data types, removing unnecessary data, processing data in chunks, use efficient storage formats. These methods reduce memory usage and improve the performance. Data type optimization. Every data type consumes different amounts of memory. Choosing the correct data type helps reduce memory consumption. For example, instead of storing small numbers using large integer types, we can use small integer types. For repeated text values, categorical data types can reduce memory usage. This is useful when processing millions of records. Chunk processing. Chunk processing means dividing a large datasets into smaller parts. Instead of loading the entire datasets into memory, we process one portion at a time. For example, a company has a 10 GB sales file. Instead of loading the complete file, we process it in smaller batches. This improves memory usage and prevents system crashes. Diagram explains how chunk processing works. Here, the large dataset is divided into smaller chunks. Each chunk is processed separately. After processing all chunks, the final result is combined. This method is commonly used in big data application. Sampling techniques. Sampling means selecting a small portion of data that represents the complete datasets. It reduces processing time. For example, instead of analyzing millions of customer records initially, a company can analyze a sample to understand customer behavior. Filtering data. Filtering removes unnecessary data before processing. Only record columns and records are selected. For example, sales analysis, we may only need product name, sales amount, and date. Removing unnecessary information may improve the performance. Data storage formats. After collecting and processing the data, the important step is storing of data efficiently. Different application uses different storage formats based on their requirements. The commonly used data storage formats are CSV for simple tabular data, JSON for web and API communication, Parquet for big data analytics, and database for large structured storage. The choice of storage format affects storage size, processing speed, and accessibility. For example, a small business may use CSV files where a large organization may use databases or big data formats. CSV stands for Common Separated Files, the simplest and most commonly format for storing tabular data. It stores information in rows and columns similar to an Excel sheet. Advantage is it is easy to read, supported by almost all softwares, simple data exchange formats. For example, a company can store employee details such as employee ID, name, department, and salary in CSV files. However, the CSV files are not efficient for very large datasets because they do not support advanced data storage features. JSON stands for JavaScript Object Notation, mainly used for exchanging data between applications. JSON stores data in key value pairs, mainly used in web applications and APIs. Examples: in weather application receives temperature, humidity, and location data from an API in JSON format. The advantage is it is a lightweight format, easy for applications to understand, support nested data structures. Parquet format. It is a column-based storage format designed for big data applications. Unlike CSV, which stores data row by row, Parquet stores data column-wise and makes data retrieval faster when analyzing specific columns. The advantage it requires less storage space, faster processing, suitable for large-scale analytics. If a company analyzing customer purchase history, it can quickly retrieve only the record columns such as product and sales amount using Parquet. Databases storage. Databases are used to store and manage large amount of structured data. There are two major types: SQL database. SQL database store data in tables. Example: MySQL, Oracle, PostgreSQL, NoSQL database. NoSQL database handle flexible and large-scale data. Examples: MongoDB. And for example, in real-time application, bank uses database to store customer accounts and transaction details securely. Choosing their storage formats. The selection of storage formats may depend on the application requirement. CSV is suitable for simple data sharing. JSON is suitable for web applications. Parquet is preferred for big data analytics. Databases are used when data needs security, reliability, and frequent access. So choosing the correct format improves the performance and efficiency. Programming tips for large data processing. When processing large data sets, writing efficient program is important. Poor programming methods can increase execution time and memory usage. Important tips include avoid unnecessary calculations, use optimized libraries, process data efficiently, reduce the repeated operations. Efficient program helps handle large datasets smoothly. Efficient file reading. While working with large files, loading the complete dataset is not always required. We can improve the performance by reading only required data. So the techniques include select only the required columns, read the data in batches, use chunk processing. For example, if we analyze sales account, we do not need customer address information. Remove unnecessary data will improve the speed. Vectorization. Vectorization means performing operations on complete data arrays instead of processing each record individually. Traditional loops take more time when handling millions of records. Libraries like NumPy and Pandas use vectorized operations for faster computation. For example, calculating total sales for thousands of products can be performed faster using vectorized operations. Memory management. Memory management helps maintain system performance while processing large data sets. So the important practices are removing unused data, releasing unnecessary variables, monitoring memory usage. For example, a data scientist working with large data sets remove temporary files after processing to free memory. Parallel processing. Parallel processing means dividing a large task into smaller tasks and executing them at the same time. This reduces processing time. A real-time example is a video streaming platform processes millions of user requests simultaneously using parallel computing. Big data system like Spark uses parallel processing techniques. Pandas chunk processing. This example will demonstrate processing a large dataset using chunk. Instead of loading the complete file into the memory, the datasets are divided into smaller parts. Each part is processed separately, and this approach is useful when working with very large files that cannot fit into memory. A company analyzing millions of scale records can process the data month by month instead of loading all records together. Applications, healthcare. Healthcare generates huge amount of data every day. So it includes patient records, medical images, laboratory reports, sensor data. Efficient data handling helps hospital analyze patient information, identify the patterns, and supports better healthcare decisions. Example is the disease prediction system to analyze previous patient data to identify the health risk. Second application, finance. In financial organization handles millions of transactions daily. Data handling is used for fraud detection, risk analysis, customer behavior analysis. For example, the bank analyzes the transaction patterns to identify unusual activities and prevent fraud. E-commerce application. E-commerce platforms generate large amount of customer data. This includes search history, purchase record, customer reviews. Data handling help companies understand customer preference. Example, in online shopping websites recommend products based on previous purchase and browsing history. Big data tools. When datasets become extremely large, traditional tools are not sufficient. Big data technologies are used. Examples Hadoop, used for distributed storage and processing. Spark, used for fast, large-scale data processing. Cloud platform provides scalable storage and computing resource. The other examples AWS, Azure, Google Cloud. So in this section we have learned about data handling and its importance in data science and challenges in handling the large data sets, how to optimize the memory, what are the different storage formats, the programming techniques for efficient processing, real-time applications, and how to handle the data efficiently. By handling the data efficiently, it improves speed, accuracy, and scalability, which are essential for modern science applications. Thank you.